Okay, so I have duplicated this joint A up here. Okay, so just to sort of make it less crowded. Alright, so this is standalone joint A free body diagram. So I have this reaction force RA. Okay, you don't actually have to have a subscript Y because RAX is 0. So the only reaction force, okay, it's vertical. So you just call it RA. Okay, just simplify a little bit. You have these two forces, okay, coming from these two members, okay, so FAB and FAC. And here I figure out that FAB points into the joint, FAC goes away from the joint. Okay, so these three forces together will make this joint A be in equilibrium in the end. Okay. Now, knowing that FAB points downward into the joint, what does that mean as far as compression or tension go? What does it imply for this member AB? Is member AB under compression or is it under tension? Knowing this FAB goes into the joint. Well, it's where physics, okay, comes in, right? Or in more principle of physics. Newton's third law, okay, in particular. Look at this joint A and this member AB. Right? Just focus on these two guys right there. That's two separate things now. Right? Joint and a member. However, this is A, this is also A. Okay? It's just that I separate this A joint outside, okay, of this member AB. Okay? Now, this is a force, FAB, coming from this member. Okay? It goes into the joint this way. Newton's third law tells us for any object in equilibrium, for every action, there has to be an equal but opposite reaction. And the reaction force is exactly this. Okay? This is FAB going into the joint, coming from member AB. At the same time, this equal but opposite force, we'll just call it negative FAB, must exist. And this force, okay, points up. Okay? And that's coming from joint into this member AB. And together, they cancel out. Therefore, it's an equilibrium. Okay? So this is Newton's third law. Okay? Equal but opposite reaction. Now, look at this now. Look at this blue arrow coming up into the member. At the same time, in order for this member to be in equilibrium, and knowing that this is a simple truss, and simple truss means each member is a two-force rigid body, a two-force member. That means this is the first force, the second force must be pointing this way, okay, along the same direction as AB, but the opposite direction of this guy right here. Since this is a negative FAB, I'm going to call it positive FAB. Now, look at this picture. Look at this AB member picture. You have these two forces coming to each other, okay, trying to make this AB shorter and shorter, right? Trying to compress AB. Therefore, FAB represents a compression force. Simple as that. Newton's third law. Okay? So FAB is a compressive force. Okay? So by using third law, okay, so we figure out the direction of this guy, And then by knowing that this is a 2-force rigid body, you know the direction of this guy. So look at this picture right here. That's how to figure out whether a force is a compressive or tensile force. Okay, so FAB is a compression force. What about FAC? Use the same method to figure it out. FAC points to the right, away from the joint, because of Newton's third law. An equal but opposite reaction must exist. Right? So this is negative FAC. Now, because of the fact that this is a 2-force member, this opposite force must exist at the other end. Now look at this picture right here. Just the member. I have a tension force. Okay? So FAC is a tension force. That's all. Okay? So this is the whole point of using joint method, right, to help you figure out FAB and FAC and figure out the direction of FAB and FAC, as well as whether or not FAB is a compression or tension force, okay, by using third law. Okay? So you can just keep going, right? So for the rest of the joints, okay, and figure out the directions and everything. Okay? Here, let's do the math. Let's try to calculate FAB and FAC. Okay? Now that we have figured out the directions of these two unknown forces, right? Let's find out the equations. Our A, I know from before, is 1/2 of the load. Now, load is a given quantity. Okay? We do know that. So, our A is a known quantity, which means that in this three-body diagram, I have two unknowns. Two unknowns means I only need two equations. Well, do we have two equations? Equilibrium conditions? Yes, we do. Okay. This is a joint. A joint is a point. It's a particle. Right. So now actually we're looking at a particle. Okay. Equilibrium condition for particle. That's it. And since it's a two-dimensional space, so we have two components of this equation. Right. So I have sum of forces x equals 0. Sum of forces y equal 0. That's all. Okay, so apply each equation to the entire free body diagram. Okay? So let's do that. Equation 1, sum of forces x equals 0. And just rewrite it here. Left hand side, what do we have? Just look at all the forces in the x direction. Now I have FAC. FAC points to the right, so it's a positive number. What else? Well, I have FAB x component. Right? So let's draw the component. Right? Once again, use dashed lines for component. Okay? And make some space. So this is my FAB. This is my FAB, comma, y. And this is my FAB x. Okay? So, in this equation, I have FAC and I have negative FAB x. This guy right there, going to the left, right, in the x direction. But since it's point in the negative x direction, okay, I right away just build that here. Okay, build the negative value here. Okay, and that's it. There's no other x forces. Let's go 0. Okay. Now in this equation, I don't know any of these. So there are two unknowns. Okay, so that's okay. Leave it there for now. Continue on to the second equation, right? So sum of forces, y equals 0. Look at the entire free body diagram. Right? Point out how many forces are in the y direction. First of all, I have this RA, reaction force at A, points up, so it's positive. What else? Well, I have this FABY, pointing down, so it's negative. FABY equals 0. That's it. There's nothing else, right? So left-hand side, only these two vertical forces. That's all. And that's it. So in this equation, I have only one unknown, FABY. Okay? Since RA, we know that. So FABY equals RA, and RA equals 1/2 of your load. Okay? Okay. So you solve for FABY, okay? Whatever it is, right? It's a known quantity, right? So that has been solved for. Now, knowing the y component, okay? Can you find the x component? And can you find this hypotenuse, FAB? Well, if you know the shape of this triangle, then yes, you can. In designing a truss, obviously you have to know the direction of this FAB, right? And this BD member, okay? And what kind of triangle it is, okay? The length of each member, right? Knowing the length and knowing the angle, okay, then you know exactly what kind of triangle it is, right? In this case, this example, this right here, okay, I want you to focus on this triangle. Now, this triangle consists of 3 different forces. Okay? This is FAB, FABY, and FABX. These 3 guys share a very special relationship. First of all, recognize that they all have the same subscript, the base subscript, FAB something, and FAB something else. Okay? And second, they belong together. These two, FABX and FABY, are the components of FAB. Okay? They belong to FAB. Okay? And they form this special triangle. Okay? Now this is exactly the same triangle that you use to help you figure out FABX, knowing FABY. So FABY, you just solve for it. Is equal L over 2. Okay? So knowing that and using this special triangle, you can calculate the other 2. Okay? But this is the only triangle you can use. Don't bring in anything else. Okay? I don't want to see this RA appearing in this triangle that you're trying to use, right, to calculate the other 2 guys. Right? RA has nothing to do with this. Similarly, FAC has nothing to do with this. Okay? This is a special triangle. It's a right triangle, 90 degrees. Okay? And depending on the slantedness, right, the angle, okay, then you know exactly what kind of triangle it is. Okay? So knowing that, then you can find out FABX as well as FAB. Okay? So this is just a hypotenuse. Right? So this is like the intermediate results. Okay? And using geometry, you can find out FABX and FAB, which is one of the unknowns. Okay?